So I think there's probably a lot of hidden benefits to seaweeds. Things like
Pigments.
Cosmetics.
toothpaste,
Plastic type materials.
instant hot chocolate,
As a bar snack.
ice cream,
Face creams.
Natural colourings.
Burgers.
garden fertilisers,
Soaps.
sushi,
Antimicrobials.
preventing coastal erosion.
Scientists like myself have been dreaming about the green revolution for a long time, but we've been working in isolation and working on our little part of it. And projects like SeaFEED are exciting because they bring together the engineers, the biologists, the chemists, the companies as well, everyone that's required to basically deliver things in a brand new way.
So where we're based here in Strangford Lough, there's quite an extensive history of growing seaweed. So it used to be a really very basic thing of putting stones out in lines and allowing the seaweeds to settle and to grow and then harvesting them at low tide. But the intertidal is a small area and it's probably not the ideal area to be thinking about setting up large-scale seaweed farms. So we have to try and kind of apply novel methods to growing these intertidal species.
So on this project we're working on fucoids, which are intertidal seaweed. So the high value compounds that we're interested in are marine polyphenols or fluorotannins. So basically they are being trialled as a replacement for zinc oxide in animal feed.
Seaweeds produce secondary metabolites such as polyphenols, known for having antimicrobial and antibacterial properties. And because of this, are being investigated for their use in industries from human health to agriculture. So in particular in agriculture, zinc oxide was used traditionally in pig feed as this therapeutic agent to reduce post-weaning illnesses and increase weight gain in piglets. However, zinc oxide was recently banned in the EU due to its environmental and health impacts as it was becoming this major contaminant. So the SeaFEED project aims to find a natural replacement for this zinc oxide in pig feed using the intertidal seaweeds through a series of sustainable approaches. It's a very innovative project led at Queen's University by Dr. Pamela Walsh and involves chemists, engineers and biologists from across the whole island of Ireland, and is helping to open the gates for developing seaweed biotechnology.
So we have essentially like this fucoid maternity ward. The fucoids like to attach to a harder substrate from, as you would expect to see in the intertidal zone. But if we want to start scaling this up the same way that people grow kelp at farms, we have to start looking at growing them on twine. Us growing it on lines is very new. It hasn't actually been done before.
So when we use our long lines out in Strangford Lough, we have quite a large site. We're only growing the seaweeds on that site for maybe a maximum of 6 months. During that time, they seem to have a benefit to the environment. We see lots of juvenile fish. It's also a habitat which during that period of time we don't have any fishing going on in. So it's effectively creating like a very small no-take zone and essentially have quite this nice little habitat that is there for 6 months.
So I've already prepped our long lines, which are going to be deployed at the site. So basically the site is made up of a series of different moorings and we deploy the ropes in between. So we're going to deploy 2 30-metre lines today.
And it'll just be a matter then of time. So when we feel it's ready to be harvested, we'll detach those lines and bring everything back in again.
Well, green and sustainable goals are absolutely at the heart of everything we do. You know, it is my identity as a scientist, and it's also deeply in this project in SeaFEED. So the role of chemistry in a biorefinery is to go from the raw biomass to the products we would use. A lot of the chemistry that we're applying is new chemistry. So if you do a clever extraction, you get a more concentrated soup, if you like, of what you require. And in our case, the 2 main components we want are the antimicrobial chemicals, which will then go into the animal feeds, and the materials components, which can then go into various different things, and so that everything is very benign and very green and very sustainable.
So when we're looking at this seaweed project, we're trying to develop more sustainable agriculture and more sustainable animal feeds. And the question then arises, how do we know if it's sustainable or not? So life cycle analysis is a technique for investigating the environmental impacts of a system. We look at the process from cradle to grave. We look at the extraction of raw materials, right through processing, transportation, and then recycling or waste or so on. And we look at all the inputs to and outputs from the system, and then look at the environmental impacts. So for example, the carbon emissions associated with each of those inputs and outputs. So for the industry themselves, it'll enable them to identify those hotspots and design the system so that it is as environmentally friendly as it can be.
So as we work towards net zero, industry plays a vital role in ensuring that their products and processes are greener and more sustainable. And at Queen's University, we're working with companies locally and globally to develop these new, innovative, greener solutions to pressing environmental issues.